looks like we are going here. This is the first time I'm doing this, so if you guys can already hear me now, just trying to get this going. I was trying to do what I normally do, which is I do recording and get it all set up and just go at it and then and then record it, put it on YouTube. But that didn't want to work out today for a couple different reasons. So we're gonna try to just go and stream this bad boy here. So we're going to go straight into simplifying rational expressions. And let me know if you have any comments as we go along here as you're watching this. But I'm just going to jump right into it here like I normally do. And we're actually going to start with number 2. I can actually cancel both of these. And you know what? Let me start with some blue here. I like to start with blue. Let's do that. So we cancel these out. Okay, 16 divided by 16 is 1. R squared over R cubed. Okay, well, R squared is R times R, right? R cubed is R times R times R. Okay, well then, what we can do is R over R cancels, and then it cancels again, and then I have one more R in the denominator. But what do I have in the numerator? Kind of nothing, but kind of not, because anything can be multiplied by 1, and it wouldn't change what's up here. So I actually have a 1 left over in the numerator. All right, so let me go ahead and go back here, see if I can go back to, where am I at? Goodness gracious, where is the thing at? Trying to get back to where I need to go. All right, am I? Here we go. So, sorry, this is the first time I'm doing this, so I'm trying to figure this out as we go. I'm going to try to maybe like go back and forth between the two screens here and just figure out what's going on as we go here. So I'm back here now at the studio looking at what's going on, and here we go. Okay, so I guess I'll need to switch back and forth here as I go, but I'm going to try to figure this out, so bear with me. It's the first time I'm doing a live stream here. So we're going to go back to number 1. And as I cross this out, I'm going to cross these out because they don't divide evenly, completely evenly, but they do both divide by 6. So one thing I can do is I can do it this way. Divide by 6, divide by 6. And if I do that, then I would get 36 divided by 6 is 6. 42 divided by 6 is 7. Now I still have these x's here. So the other thing I can do is I can do the same thing I did before. But actually, there's another way to do it that's faster. When I had R2 divided by R3, there was 1 R left over in the denominator. So what you can do is you can take the powers and you can subtract them. So right here, the difference between 2 and 3 is 1, and then the bigger power is the one that still has any of that letter left over. The bigger power here is 3, so I'm going to have x's left over in the numerator. But if I get rid of, let's say, x squared, that's basically what I'm doing is I'm saying, okay, well, there's 1 left over here, but there's none left over here now, right? So that's just one way of doing it. Not my favorite way of doing it, but it is one way of doing it. Let me show you what might be my favorite way of doing this. So when we cancel these out here, p2 over p, 2 minus 1 is 1. I'd have 1 p left over in the numerator. 16 divided by 28. Well, if you didn't see right off the bat what that might have divided by, the largest number it would divide by, which would be 4, then you would at least know, hopefully, that those both divided by 2 because they both end in 0, 2, 4, 6, or 8. So if I divide them by 2, I get that and that. And then I can divide them by 2 again. I get that and that. This is my favorite way to do it because I just slash and slash and slash until there's nothing left. And then whatever's left over is the answer. I have 4 and p in the numerator, and then I have 7 in the denominator. All right, that's my favorite way to do it, and that's the way that I'm going to do it from here on out, because I think that's the fastest way, and that's the way that I think you want to build into. 32 and 24 both divide by 8. That goes in 4 times, that goes in 3 times. N squared over n, I have n left over, so I have 4n over 3. Not so bad, right? Okay, so I'm actually going to do, I think I'll do like maybe 6 at a time with one color, and then I'll switch from there. Or, you know what, let's do this. Let's go to like a light blue instead. Okay, so now we divide by the largest thing we can. 70 divides by 7, 28 also divides by 7. That's not the largest thing they divide by, but you don't have to divide by the largest thing. Not right off the bat. Not if you don't think of it, and that's fine. So sometimes I'll just divide by one thing as we go along here. As we keep going, though, I will start dividing by the largest thing that divides by each number. So for instance, 15 and 30, 1 and 2, and then I have n squared on the bottom, so 1 over 2 n squared. All right, then for number 7, I have 2 r minus 2, and then r minus 2 down here. Boom, boom. So I have 2 left over. Not so bad, right? So here what I did for number 7 is a little different, but I factored out a 2 first. So I took out a 2 because both of these things divide by 2. So kind of what I did was I said, let's do this maybe, group it all together. So what I did was I said, okay, well, 2r minus 4. Both of these divide by 2, so what happens if I divide them by 2? Well, I would have r left over if I divided that by 2, and I'd have 2 left over if I divided that by 2. So that's kind of what you're doing. When you factor, you divide. So I'm dividing both of those things by 2, and that 2 comes out as a factor. That's the greatest common factor. That's how you factor out a greatest common factor. And then, if the binomials are exactly the same, you can cancel them. If they're not exactly the same, you can't. All right, so let's do the same thing for number 8, 45. You can factor out 10. And these both divide by 5. So I end up with 9 over 2a minus 1. And that's the answer I get for that one. Okay. And as I go here, I'm going to continue to go back to our live stream. I don't know how else to do this, so just I can check to see what's happening as we go. Looks like, and I've never done this before, and this is, at the time of me putting this out, this is still a younger channel with only like 100 subscribers or so, so I'm not expecting anybody to jump in and be like, oh, hey, what's up? But if you do, then you are welcome. And you can ask me any questions about this as we go. No snarky comments, please. Give me some grace here. Just figuring this out for the first time. I know. Crazy. So what we would do for number 9 is we would divide each of them by 3x, 3x. So when I do that, I get x left over there, x squared and x. And then here I'd get 4 left over. Oh, look at that. X minus 4, x minus 4. So I get 1 over 3x. Okay, what about number 10? Well, both of these divide by 3. So that would be 5a minus 1. And then on the bottom, it's, well, just 24. But 24 divides by 3, and it goes in 8 times. So this is 5a minus 1 over 8. All right, so then we get to the last 2 on the first page. So we're almost halfway there, at least numbers-wise. And now we have our first couple trinomials. Well, if you're going to factor a trinomial, you do it a little bit differently. And I've got other videos on trinomials and how to factor trinomials as well. I've done lots of work on factoring. So go check out some of those other videos on factoring if you like. But this is going to be, you're going to want 2 things that multiply to 25, which there's only 2 pairs of things. 1 times 25 and 5 times 5. We want those numbers to add to negative 10, though. So negative 5 times negative 5 is positive 25. Negative 5 plus negative 5, though, is negative 10. And that is how you factor a trinomial. So this is v minus 5 over v minus 5 times v minus 5. Lots of v minus 5s. Not all of them cancel, but one of them does with one of them, just like before with the x's, right? And then we'd be left with 1 over v minus 5 as our answer. Right, same thing here. We want two things that multiply to 6, except it needs to multiply to negative 6. So one of them has to be negative, aka I'm subtracting. I want to subtract to 5. Well, 6 minus 1 is 5. So negative 1 and positive 6 are my factors. Right? And then I can actually just do this. Boom, boom. I have 1 left over on the top, x minus 1 on the bottom. All right, time to switch colors again. Go to a lighter green here. And now I'm going to factor out from the bottom. I can't just divide everything by 27. Both of these numbers are 27, yeah, but this number is an 18. You have to include all your different numbers here. So there's actually two different ways to do this. The standard way to do it would be to do it how I've been doing it, which is to factor out the GCF from the thing, and then cancel, and then, supposed to be a 3, and then write out the answer from there. The other way to do it would be to just cancel, 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 and divide each term by the GCF that it divides out. Well, each term divides by 9, so I get 3, 3, and 2, and then that would give me 3 over 3x plus 2, which is actually faster. So that's an even better method. Now, 14, again, a little different because now we have a trinomial over a trinomial. So it's not too different, but one thing that's a little different is we need space to be able to do both. So I'm going to rewrite the numerator over here and then factor it. I need two things that multiply to 30, and those same two things have to subtract to 7. Now, if you can't think of the things that go to 30, it's okay. You don't have to think of them right off the bat. Let me go back here. What if you didn't? What if you didn't think right off the bat that it was 3 and 10? Well, you could start with 1 and 30. We need to subtract because I should be getting negative 30 when I multiply, so I need to be subtracting 1 and 30, which is plus or minus 29, depending on if you do 30 minus 1 or 1 minus 30. But neither of those make 7 or negative 7. So I go on. Well, 2. It's 30 divided by 2. Yeah, it's even, so it divides by 2. And I get 15. The difference there would be plus or minus 13. So I keep going. 3 and 10. And then that's when I find out, hey, that one subtracts to 7 if I make the 10 negative and the 3 positive. And that's how you do it. All right, same thing over here. So 1 and 24, 2 and 12, and 3 and 8. All right, so then I get that. And I'm going to just basically put that here. And cancel, cancel. And I get v minus 10 over v minus 8. So there we go. All right. So then, go here. Do that. And 2 more in this color, and then we'll switch colors again. Same thing as number 14. I'm going to rewrite it over off to the side. And I have, let's see, 2 and 6. So that's going to go like that. And then the other thing, too, is once I find my factors, I don't need to write out the factors because I'm just going to copy them over anyway. So once I find the factors, which look like they're going to be 3 and 6, plus 6 minus 3, then I can write out the whole thing right here. Just find the factors, but then write out the whole thing over here because that's where it matters, because that's where you're going to cancel some stuff, and then get the answer. All right, so an even faster way. All right, an even faster way from there would be to just go ahead and straight up factor it. Well, I'm going to need two things that multiply to 18. 1 and 18? No, that would make 19. How about 2 and 9? Yeah, that would work. So x minus 2 and x minus 9. And then that's over, well, I need to factor the denominator now. So I'm going to do two things that multiply to negative 8. And how about 2 and 4? So x minus 2. X plus 4, and then I have x minus 2, x minus 2. Those cancel, and I have x minus 9 over x plus 4. All right, so that's it for those. And let's go ahead and change color again. So now we have like a lighter green. This is the only time you have, oh yeah, and I forgot that I already did work out the last 4 there, so spoiler alert, they're already worked out. But let's go ahead and switch to like an orange, so we can go ahead and get ready to where the purple comes up, so it blends a little better. But so here there's 2 ways to do it. You can either do square root on the bottom here, and then you would have b minus 7. If I did the square root of b squared, I'd get b, and if I did the square root of 49, I'd get 7. And then you just have to remember to do p plus 7. That's one way to do it. The other way would be if you make it a trinomial, and then I need factors that multiply to 49 and subtract to 0. Well, that would be negative 7 and positive 7. They would add up to 0. 7 minus 7 is 0. And then you could factor it that way as well. So 2 different ways to factor it. You get the same answer. It is faster to do a difference of squares. That's how they normally teach it to you. But until you've got the difference of squares kind of factoring down, it might be helpful to write it out as a trinomial first. So let's go ahead and factor the top. I kind of skipped straight to the bottom there. Let's factor the top. If I take and find factors of 28, I'd have 1 and 28, 2 and 14, skip 3 because 3 doesn't go in, 4 and 7. There we go, 4 and 7. So 4, 7. I need it to subtract to 3. 7 minus 4 is 3. So those are the factors that I want. Put them over the factors that I have here. That cancels, and that is my answer. All right. So 40. 4 and 10? No. 5 and 8? Yes. And again, if you don't think of the factors right off the bat, that's okay. Just list them all out and add or subtract each and every one until you find the answer. It takes a little bit of practice to kind of just think of the factors right off the bat. V is going to be minus 3 and V minus 8. Cancel, cancel. There's the answer. All right. So then we can move on to the next one. I'm going to go ahead and keep switching colors here so that we keep transitioning into the purple, and I'll just leave these purple solutions down here at the bottom to save a little bit of time, I guess. But let's go ahead and look at 19. So remember, you can take out the GCF of each one, or if you know that all of the things divide by the same thing, you can divide everything by that same number. You have to be kind of careful when you're doing that because it's a little tricky, but it is a little bit faster. Each of these numbers divides by 2, so that would be 2n minus 2 over 3n minus 5. And I can factor the top there a little bit, but it's not going to matter because it's not going to cancel with anything. And I almost put a plus there. Let me fix that. It's not going to cancel anything. So really, either of these answers would be the final answer. The final answer is the answer that is most simplified, but factoring itself doesn't simplify. Factoring does not equal simplifying. We're only factoring so that we can cancel. If you can cancel stuff, then there's less stuff. If there's less stuff, that's more simple, right? If you have a bunch of stuff, if you own a ton of things, then your life is a little bit more complicated. You have to upkeep with more things. You have more things to keep track of, more things to clean, more things to, you have your 1 car, 2 cars, 3 cars. If you have 3 cars, you need to have all of them serviced every now and then, oil changes and whatnot. More stuff, more upkeep, less simple. With numbers, that's the same thing. That's why it's called simplifying. We're trying to cancel so that there's less numbers and letters so that we have a more simple thing. So factoring does not equal simplifying. Canceling equals simplifying. All right, so with that in mind, let's go ahead and move on to the next one. We want to factor the top, and we would do 7 and 2, minus 7, positive 2. On the bottom, we'd have v plus 2 and v plus 2. V plus 2's cancel, and because I canceled, I simplified, and I got a nicer answer. All right, on to the last 2 that I actually already, haven't solved yet, or at least on this particular version here. These are a little harder, but we can still divide everything by a common factor. Everything divides by 2, so divide that by 2, divide that by 2, divide that by 2, divide that by 2, and divide that by 2. Lots of things divided by 2. If you're going to divide by anything out of every single term on the top and the bottom, it has to be done to every single term. So for instance, almost every single term has a v in it, but not this one. So I can't divide everything by v because not everything has a v in it. So I have to be careful with that. So then from here on out, I can go ahead and continue to do a GCF. So this is 3v cubed plus 21v squared. And this is v squared plus 13v plus 42. And then I can factor out 3v, and I get v squared plus, oh, hold on, that should be v squared already. Or should it? Oh, no, yeah, this should be squared here. There we go. So then that should be v right there. And then plus 7. There we go. Okay. And then on the bottom here, I'm going to get factors of 42. So that's going to be 6 and 7 plus 6 plus 7. And I'm going to squeezing it in there, but there's the answer. I'll rewrite it right here just for clarity. V plus 6 on the bottom. And there we go. Okay. Last one that I didn't already solve. Looks like we don't have a GCF, not for the top and for the bottom, but we do have an x that factors out from the top right off the bat here. And then I can continue to factor that. 42 is 6 times 7 again, except I want minus 7 and positive 6. Then here on the bottom, I can factor out a 2. And so then I'd have x squared minus 10x plus 21. 21 is 7 times 3. And I'd want a minus minus, so that's going to be 2 x minus 7, x minus 3. That cancels. And what's left over is the answer. I don't really have space to write what's left over because I'm kind of running out of space here. But that's what's left over. So I'd have x times x plus 6 over 2 times x minus 3. You could distribute back out, but I don't think you should have to. If your teacher wants you to, obviously go ahead and do that, but I don't think you should have to. So here are the 4 that I solved. And the reason why I'm doing this live instead of pre-recorded, I'll go ahead and tell you, because if you already made it to this point in the video after I post the recording and everything like that, then here's what happened. So I was recording it on my other computer. It was not plugged into the power, and it was a little low on power, but I was like, it's got plenty of power to make it all the way through. And then, I start getting through, I get closer to the end, and then it says, low battery. And I'm like, oh, well, I'm almost done. I've only got, 6 more or so. And then, two or so more, and I'm on, the last few. And then it just decides to shut down. So I was like, oh, crap. So then I come over to this computer and just do the last 4, which were the only 4 that I didn't get around to on the other one. And yeah, so I solved them out, and I was like, oh, I'll just splice together the 2 videos. It won't be bad, I've done a little bit of video editing before. It won't be too bad. It won't take too long. Video editing takes forever. I don't know if maybe it's just this computer, because this computer is my slower one out of the 2, or what it is, but it was taking forever. And normally I, wait till the last minute to paste it, to post everything. So we're here and we're doing this. And normally I do that because that way I'm a little bit more motivated to get it done and put it out into the world. But that didn't happen today. So here we are. So this is it. These are the last 4. And let me know if you have any questions on these. But since I've never done a pre-recording, and since I've never gone live before, you already saw some different tabs open as well. So I had different tabs open. So you saw my lighter summer schedule and everything. Got everything out in there in the world. But hey, it's all good. You gotta figure it out as you go sometimes, And you know what? Years later, when I have way more polished videos, I'm gonna look back at this video and be like, yeah, that was really dumb. But you know what? It taught me that I could do a YouTube live, and you know, maybe from here on out, I'll do more and more YouTube lives, and you guys can give me feedback as I go, and let me know how that goes, and we can do more interactive videos, and you can ask me questions as we go along here. So let me know, by the way, in the comments if you would want to see me work out a particular problem. Like, let's say you have a problem that you're stuck on. We could go live on YouTube and we could solve problems, and we could just do like a Q&A session. And so let me know if that's something that you might be interested in. I might start trying to do something like that each week, along with the Tuesday normally pre-recorded videos. So let me know if that's something that you might be interested in. I'm going to go ahead and stop this recording, go back to my my Streamlabs over here, and let's go ahead and end that stream.